Hello and welcome to Math with Mrs. Becker. Today in Algebra 2, we are going to start section 5.2, where we will be graphing quadratic functions. Okay, so remember in the last section, we practiced transformations, okay? So if you transformed a quadratic function, if you did a reflection across the y-axis, what you'll find is that you actually get a mirror image, okay? So here's what the parent function looks like. X squared, and remember that's that U-shaped graph that touches at the origin. Now if you have a negative always represents a reflection. If the negative is in parentheses, so it's only going to the X, what happens is you flip it over the Y. And so what happens here is you end up with a mirror image. You can't even tell that a transformation occurred. Now the reason why this is important is because it shows us that parabolas are symmetric. And what that means is that there is an imaginary line that goes right in the middle of your parabola, and it's called the axis of symmetry, and that is your reflecting line. Okay, so again, it's the axis of symmetry. It's a line, it has to go through the vertex because it goes through the center of the parabola. And remember, the vertex is the exact center point. It's either the maximum, it's at the top of the parabola, or it's the minimum, it's at the bottom. But your axis of symmetry, it is a line, it cuts through the vertex, and it divides the parabola into two congruent halves. So that means one side will be a mirror image of the other. So remember, this is what the equation looked like when we were working towards the end of 5.1. A tells us if you have a vertical stretch or a compression. If there's a negative up front, you flipped it upside down. H, K, that is your vertex. Whatever you're subtracting from X in parentheses, that's the X value for the vertex. Whatever you add or subtract to the end, that's the Y value of the vertex. Now your axis of symmetry, it's always going to be a vertical line, okay? Because it has to cut through the parabola through the vertex. Because it's a vertical line, it's cutting through the x-axis, so the equation is x equals, because it has to go through the vertex, it is x equals h. So the really cool thing is, to find your axis of symmetry, it is the same value as the x value from the vertex. You're just writing it as the equation of a line, so it's x equals h, okay? So let's go ahead and see what this looks like. Let's say that you are given this equation, and they're saying, hey, find the vertex and the axis of symmetry. Where's that center point, and where's the line where you could, in a sense, fold the parabola exactly in half? Well, remember, the formula has a minus here. So if this is a plus, this is what you really had. You had minus and negative. That's how it changed to a plus. Your vertex, what are you subtracting from X in parentheses? A negative 5. What did you add or subtract to the end? They minus 8, so it's a negative 8, okay? Your axis of symmetry is X equals whatever the X value is for your vertex, okay? So that's going to stay the same. And it's easy to remember because this first value, that's the X value. This is X equals, so it is, again, it's using that same variable, the X. So if you were to graph this on a graphing utility, and we will be looking at Desmos in a minute here, this is what you would see. So it would give you an opportunity to go ahead and check to make sure that your vertex was at the right location, and to make sure that if you cut the x-axis 5 units to the left, would that be exactly in the center of a parabola? So this is what that graphing calculator would look like. Okay, now here's another one. We want to identify the vertex and axis of symmetry, and then check it by graphing on a graphing calculator. We are going to use Desmos.com, and I'm going to go ahead and show you when we get to that step. So again, if it helps you, remember that this was x minus. So the only way that this could end up a plus sign is if you minused a negative. So the vertex, the center point of that graph, whatever you're subtracting from x in parentheses, so it's a negative 2, whatever you add or subtract to the end, that's the y value for the vertex. So I'm saying that if this is my quadratic function, the center point is located at negative 2, negative 3. Your axis of symmetry, and again, that's that line where you could fold your parabola exactly in half. It's always x equals, because it's a vertical line that cuts the x-axis, and it's the x value from the vertex. Okay, now they want us to check it on Desmos.com. Okay, so if I go ahead and go to my phone, remember this is a free graphing calculator. You just type in Desmos.com. You will get to this screen. So we will go ahead and type this. So open a parenthesis, x plus 2, close the parenthesis, squared minus 3. So here's what the parabola looks like. If I only want to look at the graph, I can hit these double arrows, and now I can just go ahead, zoom in, and I don't see the equations. The cool thing about Desmos, if I go ahead and tap by the vertex, remember the vertex would be the lowest point in this case. When I tap, you'll notice that it gives me a little gray dot. If I tap it again, it tells me the order pair. So we can verify. So the vertex should be at -2, -3 it is. Our axis of symmetry, we said x equals -2. If I go to the left 2 and I cut the x-axis, would it go through the vertex and be halfway through the parabola? Absolutely. Okay, so again, Desmos.com, great way just to double check your work. All right, this is how you're doing on your book assignment. This is what you'll do for numbers 2, 3, 4, 12, 13, and 14. Okay, so 6 of the questions, they just want you to say what is the vertex, what is the axis of symmetry. Please go ahead and go on Desmos.com, double check your work, get comfortable with this. It's going to help you a lot. All right, let's keep on moving. Now, another useful form for writing quadratics is in what's called standard form. Now, this is a format that you have looked at in the past when you're writing things in standard form, when you are using the quadratic formula, anytime you factored, you always want it in this format. It is ax squared plus bx plus c, and you want it equal to 0. Okay, you want just either 0 on one side or f of x or y. Now, in case you're somebody who's like, well, how the heck can I have this and it both represents a quadratic? Here is the actual proof. Okay, so last year in geometry, when you guys learned different things, they proved it to you. Now, in Algebra 2, you don't have to do any proofs, but one thing that they do provide in our textbook, they show you proofs of how different things work. Okay, and so that's what this is doing. They're showing you how what they actually did is they took the vertex form and they FOILed this out, and then they distributed the A, and they're just showing you how they took this and were able to create ax squared plus bx plus c, okay? So if you're really curious how they took one equation and formed another, go ahead into your textbook. This is a really cool slide that will help you out. You can just kind of read through it. One thing that's really neat, you can still look at the value of A. A tells you if there's a vertical stretch or a compression. It also tells you if there is a reflection. If this value is negative, your parabola opens downwards. If this value is positive, your parabola opens upwards. Now, B is used if you are trying to find your axis of symmetry. Now, hopefully this is something that you do remember at least a little bit from geometry. If you are given the equation of a quadratic in standard form and you want to find the axis of symmetry, the formula is x equals the opposite of B over 2 times A. So you would take whatever B is, do the opposite sign. So if it's currently positive, you make it negative. If it's currently negative, you make it positive, and that goes on the top. The denominator is 2 times A. So you would take whatever the A value is, multiply it by 2. When you calculate that, that tells you where your axis of symmetry is. Now C, where C is really cool, this is your y-intercept, because when you're picturing your coordinate plane, this is your y-axis. In order for your graph to be on the y-axis, it means you're not going to the right or the left. So at that location, x is 0. Well, if I go here, if I put in a 0 for x and a 0 for x here, it is C. So C tells you the location on the graph where the parabola crosses the y-axis. So it's really cool how they can just go from one form to the other, and you can still identify so many different things. Okay. What we are doing now is we're going to start graphing quadratics by hand using all of those different tips and techniques that they showed you on the previous slide. This helps you a lot, okay? So properties of a parabola. You want it in the form ax squared plus bx plus c, okay? So make sure that it's in standard form, 2x's, 1x's, no x's, okay? A can never be a 0, because if this was a 0, then your x squared would not be there, and then it would no longer be quadratic. because in order to be a quadratic function, you have to have a power of 2, okay? If you want to see if the parabola opens upwards or downwards, you look at the a value. If a is greater than 0, so if a is a positive number, it opens upward. If a is less than 0, meaning it's a negative number, your parabola is going to open downwards. So I think of it like this. If a is positive, the parabola is happy, so it's smiling. If a is negative, the parabola is sad, so it's frowning, okay? Axis of symmetry. It is the opposite of b over 2 times a. So that would give you your dotted line. You would know exactly where the middle of the parabola would fall. Now to find the vertex, the cool thing is your vertex is an ordered pair. It's x, y. When you find the axis of symmetry, you already know what the x value is. So the axis of symmetry value is the first value for your ordered pair. To find the y value, you have to put the x into the original function. Then you could plot your vertex. The y-intercept is c. So remember, c is the value in your quadratic that does not contain a variable. So let's go ahead and just kind of tear this thing up, all right? Determine whether the graph opens up or downwards. That is all based off of a. A is the value in front of your squared term. It is a 2. 2 is a positive number, so your graph will open up. It is going to be a happy face, okay? Find the axis of symmetry. So x equals the opposite of b. This negative sign goes with the b. B is the number in front of x. So if I take the opposite of b, right now b is -4. The opposite of a -4 is a +4. The bottom is 2 times a. A is the number in front of x squared. So if I take 2 times 2, it's a 4. 4 divided by 4 is 1. So that means when you look at the center of your parabola on the x-axis, I go in the positive direction 1, that's going to be the center line. Your vertex is an ordered pair. You already know x. X is 1. So to find the y value, you go here, and wherever there's an x, you fill in a 1. So you guys, this is just plugging it into your calculator. You put x into the original. So I have 2 times 1 squared minus 4 times 1 plus 5. It is a 3. So your vertex is located to the right 1, up 3. Now your y-intercept, remember that x is 0. So if x is 0, it is the c value. So it's 5. Now here's the cool thing. If you're graphing, because this axis of symmetry is like a mirror image, if there is a point here, not on the mirror image, you can flip it over because it has to be congruent from one side to the other. So 1 point from my axis of symmetry, I have a point at 5 going to the left. That means also from the dotted line going to the right, I would have to have a point at that same level. Then I can go ahead and connect them. And you guys, this is it. So the next slide, I do have a visual for you. Okay, so again, this is what I got as I just sketched it off to the side, but it's just showing you we do have that axis of symmetry. Notice it is at that +1. The vertex, this is located at 1, 3, 0, 5. This just bounced over. It goes ahead and it opens upwards. One thing you could do is graph on your graphing calculator. Again, you could go to Desmos, fill this in, and double check everything. So on the next one, we will go ahead and check on Desmos. Okay, here is the function. Determine if it opens up or down. So that's always based off of a. A is the number in front of x squared. So in this case, a is a -1. Because this is negative, my parabola has to open downwards. So what that means is at the end, it's going to look like a frowning face. Find the center of the graph. X equals the opposite of b. B is the number in front of x. Right now it's -2. The opposite of -2 is +2. So that's what goes on the top. The bottom is 2 times a. A is the number in front of your squared term. So it's a -1. 2 times -1 is -2. So the x value, the center line for your parabola, is located +2 divided by -2, so it's a -1. So when I graph on the x-axis, I go the negative direction, so left. 1 unit, that's where I have the center of my parabola. To find the vertex is an ordered pair. I already know that x is a -1. To find y, I come up here and I replace all of the x's with -1. So there's a negative out front. X becomes -1 minus 2. X becomes -1 plus 3. Now notice that negative stayed out front because when you're substituting in a value for a variable, you're only allowed to change the letter. I'm not allowed to change the negative, the power of 2, any of the signs. The x is what gets to change into a -1. Okay, so here we go. Let's plug that in. Negative out front. -1 to the power of 2 minus 2 times -1 plus 3. The y value for the vertex is a 4. So if I go to the left one, I go up 1, 2, 3, 4. Your vertex is always going to be on the axis of symmetry. Now the y-intercept, remember, x is a 0. So if x is a 0, it cancels this. So what I have left is a 3. So I stay at 0, go up 1, 2, 3. Now, this point is not on my axis of symmetry. So that means I can reflect it over because it has to be a mirror image. Once you have 3 points, that's enough to connect and you would have your parabola. Okay. So again, if I want to check this on Desmos.com, I just type in the equation, -x squared minus 2x plus 3. Okay, so we can go ahead and check. We said it should open downwards. Yep. We said our vertex should be the ordered pair -1, 4. It is. Okay. Our axis of symmetry has to go through the vertex. So we said it's go to the left one. Absolutely good to go. We said our y-intercept, where it touches the y-axis, should be at 0, 3, and it is. So Desmos.com is a really cool way to go back and check your work. And again, I provided a little screenshot for you where it just says step by step, what would you do? So this was the previous example. Okay, so you'd sketch that axis of symmetry, make sure you have that dotted line there, plot the vertex, plot the y point, and then you use the axis of symmetry to go ahead and flip it over, check on a graphing calculator. Okay, so again, just being able to compare the two. Here's another one. And you guys, I think this might, oh no, we have 2 more. Good. I thought this was our last one. I don't want it to be the last one yet. Now notice this. There's not a c, because remember it's ax squared plus bx plus c. Well, -2 is the a because it's in front of x squared. -4 is b. There's not a c, so that's the same thing as if it was plus 0. Okay. This says determine whether the graph opens up or down. That is based off of the number in the front. A is equal to a -2. This is a negative value, so your parabola is going to open downwards. Your axis of symmetry, x equals the opposite of b. B is a -4 because it's the number in front of x. The opposite of a -4 is a +4 over 2 times a. A is -2. 2 times -2 is -4. +4 divided by -4 is -1. So you'll notice I already have that dotted line there for you. That's your axis of symmetry. Now to find the vertex, the x value for the ordered pair, we already know that that's -1. To find the y value, you go back to the original equation. Wherever there's an x, you plug in a -1. So let's go ahead and do that. -2, plug in a -1, minus 4, plug in a -1. The y value for the vertex is 2. So I go to the left one, up 2. Find the y-intercept. If you put in a 0 for x, this is 0, this is 0, there would be nothing left. So it's actually at 0, 0. Now, you flip the point that's not on the axis of symmetry. You reflect it over to the other side. We connect it. Did it open downwards? Yes, it did. Okay, one more, and this one we'll check on Desmos. Okay, so here, if it kind of helps you, I've had students in the past that right off the bat say, okay, what is A, what is B, what is C? And that just kind of sets you up for when we get to the quadratic. A is the number in front of your square term, so it's a 1. B is the number in front of x, so that's a 3. C is the number at the end, that's a -1. Step 1, determine if the graph opens up or down. That is based off of A. A is a 1, 1 is positive, so your graph is going to open upwards. Axis of symmetry. X equals the opposite of B, okay? Opposite of B, right here, B is a positive 3, so it's going to be a negative 3, over 2 times A. A is a 1. 2 times 1 is 2. So X equals negative 3 divided by 2. You could keep it as a fraction, or you could turn it to a decimal. So your X value is negative 1.5 units. So on the X-axis, I go to the left, 1.5 units. That's where my axis of symmetry is. That is your reflection line. Okay, find the vertex. Your vertex is an ordered pair. We already know the X. To find the Y, I go up here. Wherever there's an X, I'm going to fill in a negative 1.5, and that will help me to find the Y value. So negative 1.5 squared plus 3 times negative 1.5 minus 1, I get negative 3.25. Now this one is just to show you that the numbers are not always going to be integers. It's okay to have decimals. So I go to the left, 1.5, I go down 1, 2, 3, and a quarter. So there is my vertex. Again, the vertex will always fall on your axis of symmetry. Find the y-intercept. At the y-intercept, your x value is 0, and it's always C. And that's because if I change x's to a 0, this will cancel and this will cancel. So 0, negative 1. Now you go ahead and flip this over the line. So this point is 1.5 units away. So if I start on the line, I go 1.5 units the other direction and make a point at the same level. Graph the connection or graph the function. Go ahead and connect them. We said it should open up. It does. Now this one, again, I'm going to go ahead and check on decimals. So if I go and I get rid of that one, let's just enter this problem. So it's x to the power of 2 plus 3x minus 1. Okay. One thing we want to check. Does it open up? Yep, it sure does. Vertex, go ahead and tap that point. Negative 1.5, negative 3.25. Awesome. Where does it touch the y-axis? 0, negative 1. So it just verifies that, yes, we totally knew what we were doing. Okay, your assignment for the first part of 5.1, just practicing these skills, is numbers 1 to 7. And then jump ahead and do 12 to 20. And you will find those questions in your textbook on page 328. I hope you had a great time graphing quadratics and parabolas today, and I'll talk to you soon.